Hey guys, today you will be doing the Newton's second law worksheet. Some of you may have already done the mini labs. If you have not, this will help prepare you for the mini labs. And if you guys have already done the mini labs, you guys should kind of understand a little bit more what's going on with this worksheet. With that being said though, I still want to go through, there's 4 problems on here, but I did the first one as an example. So just as a review, Newton's second law states that force equals mass times acceleration. So the main thing that it focuses around mass and acceleration. Today you guys will be doing the Newton's second law worksheet. Some of you guys may have already done the Newton's second law mini labs, which is great. It's very similar to the mini labs. Those of you guys who haven't done those yet, you guys will be doing those in class later this week, and this will kind of help you guys get ready for that. So there's 4 examples or 4 questions on this worksheet, but I did the first one for you guys so you guys can kind of see how it's done and how I expect it to be done, and I'm also going to go through that example with you guys. So just to start, Newton's second law is force equals mass times acceleration. So the whole law hinges around how force, mass, and acceleration relate to each other. So if one increases, what does the other one do? Okay, or if one decreases, you know, maybe this one will increase, whatever the case may be. So the first example I give you guys is some research scientists wanted to study the durability of several competing cell phones. They dropped several smartphones from 2 meters to see which sustained the least amount of damage based on the force in which they hit the ground. The iPhone 11 has a mass of 193.91 grams. The mass of the competing model, a Samsung Galaxy S20, and let's be honest, I made this up. I don't know if that's the actual competing brand. So don't correct me if I'm wrong, is 197.88 grams. And finally, the mass of a Google Pixel 3 is 147.98 grams. Which phone do you think would sustain the least amount of damage from the fall? So you guys will always have a question that starts off just kind of asking about your guys' setup. So again, just to review, iPhone is 193.91. Galaxy is heavier with 197.88, and the Google Pixel 3 is 147. So this one's the smallest or the lightest one. Okay, so I said that just based on the mass alone, this one has the smallest mass, so the Google Pixel 3 will hit with the least force. So that was my why right there. So explain why. It has the smallest mass and therefore should have the least amount of force when it hits the ground. Okay, one big thing that I need you guys to understand with this, and I address it in part C, is that if you drop 2 objects, a bowling ball and a tennis ball, okay, obviously those 2 things have different mass, and this is something that we go over a lot with gravity. They fall at the same time. Unless there's something different in the air resistance, those 2 balls have the same acceleration due to gravity because we're on Earth, and they will fall and hit the ground at the same time, assuming they're dropped at the exact same time, okay? That's a big misconception. A lot of people will say that the heavier object will hit first. That's not true, okay? So if you guys keep that in mind, these 2 phones or these 3 phones, if we dropped them all at the same time, they'd all hit the ground at the same time, but one would hit with more force, okay? So your heavier phone would hit with more force. All right, so in the if the 3 variables for Newton's second law are force, mass, and acceleration, what is the constant of this experiment? So again, the constant is the one thing that we don't change. Okay, we keep it the same in every trial and every test. And if we are dropping them from the same spot every time, and we're dropping them all from Earth, so they're subjected to the same gravitational pull, then acceleration is what we keep the same every time. We're not dropping one from the moon and then one from Earth. Okay, so acceleration is our constant. We are dropping it from the same height every time, so our acceleration is the same all of our trials. So all 3 phones are dropped from Earth, therefore they have the same acceleration when they free fall. All 3 will hit the ground at the same time. Okay. Part D, of the 3 variables, which is the independent variable? So the independent variable is also known as the manipulated variable. So it's the thing that we change. Okay, by picking 3 different phones, we change the mass. Okay, we got to choose, all right, I want this phone, this phone, this phone. They all have different masses. So our independent variable is the mass. So by choosing 3 different phones, we are directly changing the mass of the phones. Okay, and then last but not least, we have E, our dependent variable is our responding variable. I like to think of this as cause and effect. Our cause was changing the masses of the 3 phones. Our effect will be our dependent variable, what we're measuring, what we're, as scientists, grabbing for our data and recording. So what is the effect or response of the change made by the scientists? So in this case, we're looking at force. Okay, we're seeing how hard we hit the ground. So again, notice our three answers for this are only acceleration, mass, and force. Okay, if you guys do acceleration for the constant, you guys won't do acceleration for the independent or the dependent. So you're only using these words each once. Okay, so, and then finally it asks about the relationship. So the relationship between the independent and the dependent variable. What is the relationship of the independent variable to the dependent variable in Newton's second law based on the observations or predictions from this experiment? Okay, so as the mass increases, and you guys would highlight increase, the force, which is our dependent variable, also increases. So the heavier our phone is, the more force it has when it hits the ground. So obviously we don't see actual results from this experiment. So you guys would just have to assume based on, all right, what do I think is going to happen? If you guys are concerned, I always think of the shopping cart analogy. If you guys have an empty shopping cart versus a heavy shopping cart, we have a different mass there. Think about how much force you would need to get them to accelerate. Okay, so you guys' next three you'll do by yourself. You will only have one of each type of example. So for instance, on this one will be a repeat. You'll have another one where you have acceleration as your constant, mass as your independent, and force as your dependent. But once you guys have that one done again on the next three problems, you won't do it again, okay? So they kind of focus on three different relationships on all three of these last questions, okay? So question two says, in the automobile industry, cars are often crashed into walls to see the effect of force on a vehicle. In this test, three identical cars are being tested. The first car is driving 25 miles per hour. The second is driving 50, and the third is driving 70. So we're all driving different speeds. That has to do with your guys' independent variables. So out of force, mass, and acceleration, which one does that apply to? Then they collide with a brick wall. Answer the following question: which car will see more damage? Okay, and then why? And then talk about your three variables. Which one did we remain constant? Which one did we change? And what was the effect, or what did you guys collect for your data on this one? Okay, question three. In an experiment, a student scientist wants to study Newton's second law. He wants to observe the impact in sand of three different kids when they jump out of a swing. The first child has a mass of 50 kilograms. The second has a mass of 45 kilograms, and the third has a mass of 35 kilograms. So this one will be different than this question. Okay, answer the following. Oops, I need to change that one. Which child will leave the smallest impact? Okay, and why? And then again, tell me what the constant is. What thing did we not change out of force, mass, and acceleration? Out of force, mass, and acceleration, which one's the independent and which one's the dependent? And then what's the relationship between the independent and the dependent? Finally, the makers of a specific brand of pinball machine are testing out new designs for their new line of pinball machines. They have their layout complete but want to design the perfect size pinball to have maximum effects throughout the machine. To do that, they need to find the perfect acceleration for the ball. For this test, they are using three different pinballs made of different materials. The lead pinball has the greatest mass of 136.11 kilograms. Another ball made of steel has a mass of 113 kilograms. And the final ball they are testing is a light aluminum ball with a mass of 50.34 kilograms. Each test will be performed by pulling the lever back to the furthest position before releasing and hitting the ball. So which pinball will provide the greatest acceleration and why? And then again, what are the constant, independent, and dependent variable, and what's the relationship between the independent and dependent? So as one increases or decreases, what happens to the other? Okay, so if you guys have any questions, please let me know. And again, if you guys have done the mini labs, this will help you. The mini labs will help you, and then this will help you guys for those of you who still need to do the mini labs. Hope you guys have a great day, and I'll talk to you soon. Bye.